Ladies and gentlemen, today I'll be presenting on phases. On our phases today, I'll be discussing on electricity or electronics. On our electricity today, I'll also be talking about classical phases, specifically electromagnetism. On this note, ladies and gentlemen, I will also be discussing on the calculation of impedance in RCL series AC circuit. On this note, ladies and gentlemen, I was told that electricity is a form of energy made from tiny particles called electrons moving from one place to another. And I was also told that electronics is a branch of science and technology that deals with the control and movement of electrons in devices and circuits. And I was also told that series circuit is a circuit in which all components are arranged in a single conducting path. On this note, ladies and gentlemen, we'll be looking at our problem to solve. And our problem is a circuit consists of 40 ohms resistor, 50 millihenry inductor, and 75 microfarad capacitor. Calculate the impedance if the frequency of the AC alternating current is 100 Hz. On this note, ladies and gentlemen, based on our diagram, we have arrow representing resistance, which is automatically equal to 40 ohms. And we also have a capacitor, which is C, automatically will also be equal to 75 microfarad. And we also have L, the inductor, which will also be equal to 50 millihenry. On this note, ladies and gentlemen, we also have our AC source, alternating current source. And we also have our frequency, which is F, will automatically be equal to 100 Hz. On this note, ladies and gentlemen, and based on the information given on this diagram, we'll be using our data to solve our problem. We say data. All our data today, we have our resistor, which is R, automatically equal to 40 ohms. And we also have the capacitor, which is C, automatically the capacitor equal to 75 microfarad. And this 75 microfarad will be changed to farad. So we say to change the 75 microfarad to farad, we say 75 times 10 raised to the minus 6 power farad. And it can still be expressed as 75 times 10 raised to the power minus 6. Means that we'll be indicating say 0 to the left. So we say 0.000001 farad. So when we multiply 75 times 0.000001 farad, automatically we have 0.0000075 farad. So we'll be using this just to solve our problem. So ladies and gentlemen, we also have our inductor, which is L. And the same thing applies here, 50 millihenry. So our inductor is 50 millihenry. We'll also be changing this to Henry. So on this note, in order to change it to Henry, we say it's 50 times 10 raised to the minus 10 power Henry. And also it can be expressed as 50 times 10 raised to the power minus 3. Means that we'll be indicating 3 zeros to the left. So on this note, we say 0.001 Henry. So we'll be looking at it automatically to solve our problem. When we multiply 50 times 0.001 Henry, automatically we have 0.05 Henry. So we'll also be using this to solve our problem. On this note, ladies and gentlemen, we say we also have our frequency, which is F, which just be equal to 100 Hz. And we also have our power, and we'll be using power to be equal to 3.14. Automatically we'll be finding the impedance, which is Z. So Z will be equal to question mark, which is automatically equal to impedance. On this note, ladies and gentlemen, we'll be looking at our problem to solve. On our problem today, we have a law representing resistance, and the unit for the resistor is ohms, and it is indicated by this sign. We also have C. C will represent capacitor, and the unit for capacitor is farad, and it is indicated by the letter F. And we also have L will represent the inductor, and the unit for the inductor is Henry, and it will be indicated by the letter H. We also have F will represent frequency, and the unit for frequency is hertz. It will be indicated by the letter Hz. Based on these information given, ladies and gentlemen, we'll be looking at a problem to solve. But I remember that resistance opposes the flow of electric current, while capacitor store energy in an electric field, while inductor also store energy in a magnetic field. While frequency is the number of vibrations or cycles per second. On this note, ladies and gentlemen, I remember the unit ohms were introduced by John Simon Ohm specifically in the year 1881. And the unit farad were introduced by Michael Faraday specifically in the year 1881. And the unit Henry were also introduced by Joseph Henry specifically in the year 1893. And the unit hertz was introduced by Henry Hertz specifically in the year 1930. On this note, ladies and gentlemen, we'll be looking at our problem to solve. Based on our problem today, we have our formula. And our formula says the impedance, which is Z, will be equal to the square root of R square plus parenthesis open. We have XL minus XC, parenthesis closes, all raised to the power 2. So remember, we also have our formula that we'll be using for our impedance, which is Z, to solve for our problem. Based on this, ladies and gentlemen, we don't have XL and XC. Remember, XL represents the inductor reactance, while XC represents the capacitor reactance. On this note, ladies and gentlemen, we're looking at them to solve in order to get our impedance, because we don't have them on our data to solve. So on this note, we say inductive reactance, and our formula we'll be using for our inductive reactance is XL will be equal to 2 pi FL. Remember that the inductive reactance is the opposition where the inductor offers to the alternating current. So it is expressed as XL will be equal to 2 pi FL. Remember, XL will just be equal to 2 times. Remember, pi is 3.14, what we have here, times F, the frequency, which is 100 Hz, times we also have the inductor, and the inductor here will be 0.05 Henry. Based on this information, ladies and gentlemen, we say XL will just be equal to, when we multiply 2 times 3.14 times 100 times 0.05, automatically we have 31.4 Hertz times Henry will automatically give us ohms. So our precise answer for the inductive reactance is 31.4 ohms. On this note, ladies and gentlemen, we'll also be finding the capacitor reactance. So in finding the capacitor reactance, we say our formula says on the capacitive reactance, our formula says XC will be equal to 1 all over 2 pi FC. Remember, the capacitor reactance is the opposition where the capacitor offers to the alternating current. Based on this information, ladies and gentlemen, we'll be looking at a problem to solve. So we say XC will be equal to 1 over, we have 2 times pi. Remember, automatically pi is expressed as 3.14. So 2 times 3.14 times F, which is the frequency, which is 100 hertz, times the capacitor. And we'll be using this to represent the capacitor, 0.00075 F, which is power. We'll be using it to solve our problem. Remember, we say XC now will be equal to 1 over, when we multiply 2 times 3.14 times 100 times 0.00075, automatically we have 0.0471. If we multiply hertz times power, automatically we have our ohms. So therefore, XC will be equal to, when we divide 1 by 0.0471, automatically we have 21.23. What we have here? Ohms. So we also have the capacity reactance, and we also have the inductive reactance. So we combine both of them in order to find our impedance. Remember, we have our formula for our impedance, and our formula says the impedance will be equal to the square root of R square plus parenthesis open XL minus XC parenthesis closes all raised to the power 2. Also remember, today we say the impedance is the total oppositions where the circuit offers to the alternating current. On this note, ladies and gentlemen, we'll be using this to solve our problem. So the impedance, which is Z, will be equal to the square root of 1 we have here R square. Remember, R will represent the resistance, automatically is equal to 40 ohms. So we have 40 ohms here, all raised to the power 2, plus parenthesis open 1 half XL. And XL answer that we'll be using is 31.4. So we'll be using 31.4 to solve our problem, please. On this note, ladies and gentlemen, I was told that impedance is the total opposition where the circuit offers to the alternating current. On this note, ladies and gentlemen, we'll be looking at our problem to solve. Based on our problem to solve for our impedance, we say Z will just be equal to the square root of what we have to say parenthesis open R. Remember, R represent the resistance, and the resistance automatically is equal to 40 ohms. So we have 40 ohms here, parenthesis closes all raised to the power 2. What we have here is plus, parenthesis open. Remember, we have the answer for XL, and we also have the answer for XC. So XL answer, that will be equal to 31.4 ohms. So we have XL will be 31.4 ohms minus XC. And remember, XC will just be equal to 21.23 ohms. So here will be 21.23 ohms. Remember, we also squared it, all raised to the power 2. So we say the impedance, which is Z, ladies and gentlemen, will be equal to the square root of. Remember, we have 40 ohms, all raised to the power 2. And remember that 40 should be multiplied 2 times. So therefore, we say 40 times 40 will just be equal to 1,600. While the unit ohms times ohms will definitely be equal to ohm squared. In conclusion or combination, we say it is equal to 1,600 ohm squared. So the same thing applies here, ladies and gentlemen. Just to solve our problem, 40 times 40 is 1,600. While ohms times ohms automatically will give us ohm squared. So on the note, what we have here, we say plus 31.4 ohms minus 21.23 ohms. What do we have? Say parenthesis open, we have 10.17 ohms. Parenthesis closes, all raised to the power 2. On this note, ladies and gentlemen, we say our impedance, which is Z, will just be equal to the square root of what we have, 1,600 ohms squared plus. Remember, we have in parenthesis 10.17 ohms, all raised to the power 2. Means that we'll be multiplying 10.17 2 2 times and also be multiplying the unit ohms 2 times. So we have 10.17 times 10.17. Automatically we have 103.4289, and the unit ohms times ohms automatically will get what? Ohms squared. In combination or conclusion, we have 103.4289 ohms squared. The same thing applies, ladies and gentlemen. So 10.17 times 10.17, we have 103.4289. While ohms times ohms automatically will get what? Ohms squared. On this note, ladies and gentlemen, we'll be using our problem to solve for our impedance. So say impedance which is equal to Z will just be equal to what we have, the square root of, if we add 1,600 ohms square plus 103.4289 ohms square, automatically we have 1703.4289 ohms square. On this note, ladies and gentlemen, to get our answer here in order to solve our problem for our impedance, we say the impedance Z, which will be equal to, we want to have our square root for 1703.4289 ohms square. Automatically we have 41.27 ohms. Ladies and gentlemen, this is our answer for today. Remember, one of the greatest physicists today who also made a contribution to electromagnetic theory today. He introduced or developed the electromagnetic theory. He was James Clerk Maxwell, specifically in the year 1864. And the electromagnetic theory states that the magnetic field and the electric field are linked together to produce an electromagnetic wave through space at the speed of light. This is the electromagnetic theory that was introduced by James Clerk Maxwell. Ladies and gentlemen, thanks for joining me on this physics journey. Keep practicing, keep pushing limits, stay curious, and let us cross the divine villages. Always remember that physics is the fundamental science that deals with the basic laws of nature. Don't forget to like, share, stay tuned, subscribe, comment in the comment section. Once again, be myself Junior, popularly or commonly known as Sketchy, the all-time record breaker. Thank you.